What is thermodynamics? So thermodynamics is a branch of science that deals with the energy conservation between the heat and another form and their interaction with the system of interest, and during this interaction it also focuses on how the properties of the system changes. So here thermodynamics basically in engineering application it focuses on the heat energy consuming and energy producing devices. Like energy consuming device means that heat pumps, air conditioning, and energy producing means steam generators, power plants. So these are the energy producing devices. So here thermodynamics, this thermo means the heat and dynamics mean the force or power. So basically these in combine the effect of heat and the force in the and their effect on the various systems. So let us we can take an example in this regard to understand how the heat changes the properties of a system. So let us consider this is a system, and it is heated continuously at a constant rate. Let us say that is q dot, and for a particular time period, that is we can say that is del t. Now during this time between at the starting of the heating and after the end of the heating, the system properties changes from the T1 to T2. Now we can calculate this total heat, this total effect of the heat on the system properties with the help of thermodynamics. So now let us form an equation, that is energy balance equation. mc into T2 minus T1 is equal to q dot into delta T. So here the C means the specific heat, and we will discuss it later in detailed manner. And now this is the equation, and thermodynamics basically deals with this that interaction of the heat and effect of the heat on the changes in the properties. Here temperature is the system properties. But here is one important thing is that the it deals only between the two equilibrium state. Now what is equilibrium state? So at the starting of heating process, the system was at equilibrium, that is called thermodynamic equilibrium. In thermodynamic equilibrium, the properties of the system takes a particular value, and at that time there is no mechanical unbalance force and heat unbalance and chemical reaction is not taking place at that time. But during the heat and interaction process during the time period del T, the system comes from the one equilibrium state to another equilibrium state. That is, at the final equilibrium state, the system is to take the temperature T2. So we can also take the another example in this regard. So this is the example we take on the basis of heat. So now we are going to take the another example. Here we will see the effect of the unbalanced force due to work transfer. Let us consider this is a piston cylinder device. From here, this is one rope is connected to the pulley. Here one electric motor is there, and it this is in at equilibrium state. Let us consider the cylinder, piston cylinder contains a gas at a particular pressure P1, V1 and temperature T1. Let us consider. So now if we supply energy in motors and it drives the pulley, and in the course of time, in the due course of time, slowly it moves, slow manner it moves in the this position, this piston moves this position. So here the gas assumed to take the final state as P2 V2. So here I assume that there is a this is the isothermal wall. So during the course of expansion there might be some heat interaction between the system and the surroundings. So this is isothermal process, we can assume, no issue. So during this process the motor has done work to move the piston, and this process we assume that this process is very slow. That's why at every instant the system passes through the state of equilibriums. So during the process means let us consider the motor. We transfer the motor amount of power is W is equal to as this is the isothermal process, so we can write from the equation of isothermal that P1 V1 into ln into V2 by V1. So I have written it. We will discuss how this form came in the later videos, but one thing is that here, one catch thing is that I just show this example here because I want to explain how the external energy changes the properties of the system from the one equilibrium state to another equilibrium state. So here we going to stop the video. I hope you like the video, and if during the course of time I will upload more videos like this, and I want to make videos of basic things of the thermodynamics and all the subject of the mechanical in the course of time, and also I want to discuss various examples, problems regarding these subjects. Thank you.